Students, in this video we will learn about the velocities of free electrons. Free electrons are having two types of velocity, thermal velocity and drift velocity. To understand the thermal velocity and drift velocity, firstly we have to understand about the free electrons. What is the free electrons? Okay, we consider about the atom of the conductor. This is the atom of the conductor. This is the nucleus of the atom, and these are the orbits where electrons are revolving. Here this is the outermost orbit of the atom, and this is the electron revolving in the outermost orbit. Okay, in the absence of external effect, this electron revolving in the outermost orbital cannot detach from the atom. Okay, now at room temperature, what is room temperature? Room temperature is taken 25 degrees Celsius. Somewhere room temperature is taken 27 degrees Celsius. So at room temperature, this electron revolving on the outermost orbit, electron get extra energy. If this extra energy getting by the electron is more than that of the attractive force between the nucleus and the electron, then this electron will detach from the atom. Okay, now this electron will free to move at any direction in the conductor. Okay, now if this electron is moving along this direction, here an atom is there, that's why this electron will collide to this atom and change their path. Okay, here another atom is there, that's why electron will also collide with this atom and change their path. Here another atom is there, that's why now here it will collide to this atom. Now this is the distance between two collision, and the distance between two successive collision is called free path, and the time taken between two successive collision is called the relaxation time. Okay, this is the motion of free electron. This motion is randomly motion, and electron is detached from the atom by the getting of thermal energy, and that's why the velocity of this electron, this free electron, will be called the thermal velocity. Okay, now let the conductor is made of the huge amount of atom. Okay, and that's why the conductor has the huge amount of free electrons. Okay, now some electrons of these free electrons can move along this direction, can move in parallel. Now some electrons of these free electrons can move to the opposite of these electrons, because the velocity of each electron will be same for at constant temperature. So the velocities of all the free electrons will be equal. That's why the average velocity of these electrons coming from left to right and the velocities of these electrons coming from right to left will be 0. Why 0? The average velocity will be the vector addition of two vectors. So if two velocities are there for first this electron and for this electron, so it will be vector u1 and plus vector u2, because v1 is opposite to the v2. v1 is opposite to the v1, that's why vector v1 plus minus vector v2 will be equal 0. Okay, now some electrons of these free electrons of the conductor can move upward direction and some electrons can move downward direction. So the average velocity, average thermal velocity of all the free electrons in the conductor will be 0. So it will be the formula U1. If the thermal velocity of first electron is vector U1 and the thermal velocity of second electron is vector U2 and velocity of third electron is vector U3, and let the numbers of electron are n, that's why the velocity, the thermal velocity of nth electron is vector un, then the average of the thermal velocity of all the free electrons will be u1 plus vector u2 plus vector u3 plus so on plus vector un upon n, where n is the number of free electrons. It will be equal V average and it will be equal 0. So thermal velocities of all the electrons is always 0. Okay, that's all. Understood.